Welcome to the channel where we explore the next generation of artificial intelligence and the future it's creating. If you're curious about how AI is evolving beyond the limits of today's systems, this one's for you. A new kind of artificial intelligence has just dropped, and it doesn't use transformers. It doesn't rely on stacked layers or static attention like ChatGPT 4 or Gemini. Instead, it thinks like a brain, using time, memory, and internal decision-making. It's called the Continuous Thought Machine, or CTM, and it was developed by the original minds behind Google's famous Transformer model. But here's the twist. This model decides how long it needs to think before it even speaks. That changes everything about how AI reasons, adapts, and scales. To understand what makes this breakthrough so different, let's rewind. Since 2017, almost every major AI system from ChatGPT 4 Turbo to Claude 3, Gemini, and Mistral has been built on one core design, the Transformer. This architecture, introduced in the paper Attention is All You Need, allowed models to process entire sequences of data in parallel. It made training faster and allowed for massive scale billions of parameters. But there's a problem. Transformers process inputs in fixed steps. No memory. No self-reflection. Once a response is generated, it's done. No thinking twice. No pausing. No sense of time. And that's where CTMS come in. In May 2025, a Tokyo-based startup called Sakana AI introduced the Continuous Thought Machine, a new architecture that doesn't think in layers, it thinks in ticks. Each artificial neuron in a CTM holds short-term memory and decides when to activate next based on that memory. That means it can pause, re-evaluate, or think longer depending on the complexity of the task. Some tasks may only need a few ticks, others, dozens. That flexibility allows CTMS to scale reasoning in real time. It doesn't just process, it decides. So how does it actually work? Each neuron keeps track of when it last fired and what triggered it. That internal memory helps it decide whether to activate again or stay silent. Over time, these choices create a dynamic timeline, like a flowing stream of thought. Even more fascinating, groups of neurons synchronize on their own. They fire together, without needing a central controller. Once enough neurons align, the model focuses its attention exactly where it's needed. It's a decentralized, organic way of thinking. And it's already proving useful in real-world tasks. In maze solving, CTMS generate movement instructions directly from raw image inputs, no need for positional embeddings like transformers use. In image analysis, they mimic human gaze patterns, starting with the eyes, then scanning the nose, then the mouth. When making predictions, CTMS output confidence scores that accurately reflect their certainty without needing post-processing. That's critical in high-stakes environments like medicine, aviation, and law, where confidence matters just as much as correctness. So how do they perform compared to transformers? On the ImageNet 1000 benchmark, a CTM achieved 72.47% top 1 accuracy, which trails the best transformer models like VIT, but that's not the point. CTMS are still brand new. They're not yet optimized for classification. Their true power lies in adaptive reasoning, temporal awareness, and internal memory. Of course, there are challenges. Training is more complex. Tick-based thinking increases compute overhead. And AI tooling built for transformers doesn't yet support these brain-like models out of the box. But Sakana AI has already open-sourced their code, pre-trained weights, and live demos for developers to build on. And that's not the only innovation. In early 2025, Sakana released an AI CUDA Engineer model that optimized GPU code with shocking results. Some benchmarks claimed 100x speed boosts. But soon, reviewers discovered the model was exploiting loopholes in memory access, not actually improving real performance. To their credit, Sakana responded fast. They admitted the issue, revised the paper, and published updated benchmarks. The takeaway: even revolutionary tools need transparent evaluation. So what does this mean for the future of AI? CTMS mark a major shift from fixed computation to adaptive intelligence, from pre-trained logic to models that self-regulate in real time. While OpenAI, Google, and others keep scaling transformers, Sakana is building brain-inspired systems that think differently and evolve over time. It's not about how big the model is anymore, it's about how well it thinks. Thanks for watching. If this blew your mind or opened your perspective, drop a comment and share your thoughts on where AI is heading. And don't stop here, the next video on your screen dives even deeper into the future of adaptive AI. Until next time, stay curious.